Hey guys, today I wanted to talk to you all about tensors. You can think of a tensor as an abstract mathematical object that's not whatever the heck that is. So if you think when you first started learning math, what you were learning when dealing with numbers was what we now call scalars. So you could have some variable x could have the number 4, you could have the number -18, 0.317, even pi. And then eventually you learned about vectors, a numerical object. It's got direction, it's got magnitude. You undoubtedly started thinking about these as kind of like arrows in space, but ultimately we need multiple quantities for that vector. Keep going on. Later, you eventually learned about matrices, where you've got a rectangular array of numbers here. And if you're kind of noticing the trend there, you might be going, oh, can I start going a little bit further? Well, yeah. So notice here we have something that looks a lot like that matrix we just looked at. But if now we start to think about in another dimension, can we take a step backwards? We can add another row on there. So now we have this multi-dimensional array of numbers. So if we look at everything we've talked about, we learned about scalars when we were little. Step up to vectors, step up to a matrix, and then to whatever this thing is. Could you go to a higher dimension than that? Well, yeah, absolutely, but we'll stick with what we have, where a scalar, we can consider that a rank 0 tensor. A vector would be a rank 1 tensor, a matrix would be a rank 2 tensor, and this dude here, this is a rank 3 tensor. All of these guys really are tensors. It's kind of just an abstract notion of how many kind of dimensions do we have to pulling in these multiple quantities into one mathematical object.